Thanks for the intro. I think you pretty much covered who we are and why we're here. One of the things that we do in the Ops CTO is we're in the emerging tech. So we have the distinct privilege of trying things out and breaking them. So Crossplane is one of the projects that we're happy to collaborate with and see how it fits into this hybrid cloud model. So today we're not going to be talking about OAM. Instead, we're going to be talking about some of the work we did to enable hybrid cloud. And I had a little story I wanted to touch on. So I started my career in tech more than 20 years ago, and I started with embedded systems development, creating print controllers for IBM. And so we had just pivoted off of using AIX and switched to Linux. And this allowed us to take commodity hardware and provide better hardware due to the lowered cost. So we had more memory in our printers, we had more CPU capability, and there was a particularly nasty problem that we were trying to debug over several months, flying many engineers overseas to Germany where the customer had the problem to try to figure out what was wrong. The printer would start printing and then it would just print blank paper, and we could not wrap our heads around it. So after many months and looking through every single line of code, we found this arbitrary comment that someone made that said, I'm just going to set this to 50 because it's not like we're ever going to have any more memory than that in the system. So one of my mentors at the time said, 90% of code is history. And that has always stuck with me throughout my career. And I think this is a good example where we talk about how we are now evolving into a cross-plane type model, an OAM model, through the history of Kubernetes. So if we start out with the Open Service Broker API specification, we looked at using this API to build service brokers to allow us to provision services on platforms as a service. You could create a broker, it provided all the information you need to connect that service, and then you connected and used it, and it was running. But the problem is that it lacked, how do we discover those services? How do we bring those to the masses? And around that time is when Kubernetes started to uptick. So we then transitioned into using the service catalog. So with the service catalog, we were then able to browse the list of managed services that were supported and offered by those service brokers. We then provisioned it and then bound it to that application within the Kubernetes cluster. So the service catalog ended up being an extension to the API of the Open Service Broker that enabled us to run that. It also allowed us to offer things such as data stores, which have been, one of the things that we've all mentioned today, easily within your cluster. So if you're following the history of that at all, what has changed in that timeline? So the service catalog came out around 2016 and has remained in alpha. So the one thing I think that has changed really is the operator framework. We've talked about operational efficiency and being able to manage our services across clusters. The one thing that was kind of missing from the marriage of these two things is how do we do these day two operations? So as the operator framework originally created by CoreOS kind of came into existence, we kind of saw that as an alternative to building the Open Service Broker API compliant service brokers. So I think everyone here is familiar with operators, but I just want to go ahead and touch on that. So operators not only provide a way to deploy the applications, as I mentioned, it also provides a way to manage them in terms of day two. So what does that mean? That means we need the ability to create, destroy, resize, failover, perform rolling upgrades, backup, and restore. And we need to be able to do that all through an operator. And we need to be able to do that at scale. And we need to be able to have a way of discovering these services just like we offered with the service catalog. So in addition to having the ability built through CRDs to have controllers, we also provide a framework to easily build the operators, provide the OLM, which is the way that we manage the life cycle of that operator. And then lastly, we provide a means of sharing this tech through all vendors within the community. And that's through our operatorhub.io. So why does any of this matter? Open hybrid cloud. That's why it matters. And I was pretty excited to see that so many people talk about that hybrid cloud is now more of the steady state. When we first released Kubernetes, if we go back to my original story about talking about how code is 90% history, we were very cloud focused. We assumed that we were going to deploy our applications in a stateless manner on a single cloud, and we wouldn't really need persistence. And if we did, we would always use the cloud to provide that persistence for us. We also wanted to leverage the services that existed within the cloud. This was a great vision, but as enterprises quickly went to adopt Kubernetes, we had brownfield applications that needed to be transitioned. We had massive amounts of data that we needed to consider that maybe we didn't want to have in the cloud or we didn't want to move in the cloud. So open hybrid cloud, as Daniel mentioned, is one of the pivotal things around our Red Hat strategy that started in 2012. And the ideas of just having everything running in one place have changed dramatically. You know, enterprises no longer want to be encumbered by building and deploying in one cloud or even one platform. And we need to think about things as we need to leverage where we can those technologies. Additionally, developers want and need the freedom to build and deploy the applications where they're optimized. It might be that they're building applications that gather sensor data and need to exist on the edge. Or they're, like Ken was mentioning, they're highly secure and private applications where the security and the data need to be kept in-house. Or leveraging the cloud for analytics processing, using different GPUs. We need to have that flexibility. So in this environment where we're hyper-focused on using the cloud services, we've transitioned more to what I want to call like a cafeteria model. We're going to pick and choose based on our needs. So with that, we require that hybrid cloud model to move where we can avoid lock-in. So I've listed kind of a set of questions that we consider when we talk about hybrid cloud to avoid this idea of lock-in. You know, how do we operationalize the applications so they're easy to deploy across these clouds? A great example of this are all the presentations and demos we've seen around OAM. How do we provide a consistent YAML that I can take and I can move depending on what cloud and what services I need to leverage? And how do I accelerate that development for my engineers? How do I abstract out the resources that I might need for my applications on things that I don't consider or don't want to know? If I'm running a service and I just need a managed database, I just want a database. I don't want to have to research everything out there. Crossplane gives us that functionality to abstract that out. How can I leverage those cloud services more effectively within my current infrastructure and architecture to improve my workload capability? And how do I manage the life cycle of these services? And if I use a specific API, how is that going to affect my movement within the cloud? Bassam touched on the managed services that Upbound is now going to be offering. And since many people are evolving to the centralized control plane, it's important now than ever to be able to have that abstraction of the services that our applications use, be able to move to have true hybrid cloud capability. And since Red Hat is a champion of the operator framework, you know, we want to provide an even ground for all vendors to contribute their applications to a wider open source community. So today, we don't have a good way to abstract out these managed services easily, and that's really where Crossplane comes in. So by creating a Crossplane operator, we're able to provide a consistent interface to these cloud providers to provision and manage the services within our cluster in a resource-defined definition. This allows us to abstract out the functionality of the service we want and to write it once and to run everywhere. So phase one of what we're going to demo today is creating the operator and sharing it with the community in a way that anyone can download it and use it and leverage it within your own cluster to build a hybrid cloud managed service abstraction. If you go out to operatorhub.io, you'll see the Crossplane operator out there, and eventually we'll have a certified operator within OpenShift. I'll let Ryan on my team talk about more of our future plans. But again, you know, we truly believe in the open hybrid cloud that there's enough work for everyone here to contribute. So go out to the operatorhub.io after this and feel free to run our demo. We also have a blog that was published yesterday that helps detail how you could run what we're doing. So without further ado, we'll go ahead and run the demo.
Basically, what we're going to show is kind of the easy button side of Crossplane, and how simple it is to kick off everyone's favorite WordPress application running in AWS. So what we have basically is OpenShift installed on OpenStack with Crossplane installed, and then basically we're going to provision an EKS cluster, an RDS instance, and that WordPress application is going to run in that EKS instance that we created. So let's review the environment a little bit. As I stated, this is Crossplane 0.11 installed on OpenShift 4.4 cluster, which is Cube 1.17 underneath. We have our Crossplane client installed, and we have our AWS client configured for access to AWS. And we've also preset up our secret credentials for AWS and created those in the Crossplane system. So just to show, when we install Crossplane from the operator, what you're going to get is some basic CRDs, right? All these resources that get installed with the Crossplane platform. We're going to take advantage of such things as the cluster package installs that we'll show a little bit, package installs, MySQL instances, Kubernetes clusters, all these types of different resources that come with Crossplane. And also, just to show that we're in a Crossplane system, namespace, and then our pods, you can see that we have, once installed, you have a package manager running, and you have your Crossplane control plane running. And here's our secret that we created. So next, we're going to provide or install these packages that Crossplane kind of pre-publishes that gives us a way to quickly and easily spin up these types of applications. So we're going to install the AWS provider package and the AWS sample package. And the AWS sample package is kind of a good jumping off point for AWS, all the internals. It sets up all of the network resources and all that type of internal communication that you need to run applications in AWS. And the cool thing about this is as we install these and let it download and run is, we're doing all of this with basically 3 commands. And we're going to have a fully operational WordPress application when this is all said and done. So what happens is now we're going to wait for the packages to install, and what will happen is they will turn ready column to true. So at this point, what you have is some additional controllers that were installed. And to show those, we have our AWS provider controller and our AWS sample controller. They're both sitting there ready to take requests. Next, we're going to do one of those requests. We're going to do a resource claim request to spin up our sample AWS environment. So let's look at the YAML that we need to create this. And basically, it's real simple. All we're doing is telling our Crossplane implementation that, hey, we're going to use these account creds, which is our secret, and we're going to do this in US West 2. We're going to call it My AWS, and it's going to do everything for us in the background. So let's apply that. Okay. So at this point, we're going to see that we have a provider created and we have our AWS sample object created in our environment. And now notice the CRDs. A lot more have been installed at this point. A lot of the sample AWS stuff, such as IAM, subnets, VPCs, all that stuff is installed and ready to be managed by Crossplane. And there's a much bigger list than when we first installed just the Crossplane application. Also, some resource classes become available to us. So for example, we have this EKS cluster class that now we have available to our cluster, and some RDS instance classes, MySQL and Postgres, that we're going to utilize when we spin up this app. So next we're going to install the WordPress package. And it's just like the other pre-published packages, it's going to have this application spun up for us and ready to go and create the resources that we need. So I'm going to create a new namespace or project in OpenShift for WordPress to run in. And then we're going to install the package. And that takes a second to download, but there we go. So it's installed now. So it's similar to the other packages. We wait till this is ready true. And once it is, it's also ready to serve Crossplane and resources. So in our WordPress namespace, you can see that the Crossplane app WordPress controller was created and running. So it's ready to receive requests. Okay. So let's create a request. Just like before, we're going to create a simple YAML to make a claim against this WordPress application. And the key here is this provision policy. Within Crossplane, you can set targets. So you don't need to provision a new cluster. We're provisioning a new EKS cluster at this point for this demo. But you could, if you had an existing cluster you wanted to run on and your target set up within Crossplane, you could define that in the spec, and that's where Crossplane would schedule the job to be completed. So let's apply it. Now this part, once this gets applied, it's going to take anywhere, if I've seen it, go between 10 and 15 minutes for everything to spin up. But once it does, what you'll see is you can check this Kubernetes applications and you'll see that, okay, we've got desired 3 submitted. That looks good. It's up and running. And then also with that, you'll see your MySQL instances. You see that's bound under the status. And then Kubernetes clusters, and that's also bound. So we have, at this point, our application running and an EKS instance that we spun up, connecting to an RDS MySQL instance, all running within AWS, controlled from our control plane and our OpenShift cluster. So the last step here is to simply access the application. And to do that, we're going to look at the Kubernetes application resources, specifically the My WordPress service, which will give us the load balancer, which was automatically set up for us when this application came up. And we'll be able to access it through browser. So we're going to highlight, there it is, the load balancer. You throw that in a browser, and you're up and running. And there it is. So that kind of concludes my part of the demo. And, you know, earlier it was brought up, if you're kind of new to Crossplane and just want to get familiar with it, I think this is a great demo to be able to do, and you can kind of explore all the different resources and all the objects. It's a good jumping off point for people new to Crossplane. So with that, I'm going to pass it over to Ryan, who's going to wrap it up for us.
So what's next? So what we'd like to do is to help kind of continue on the path that the operator is on right now. Right now, you can install the operator, and as of last night, it just went to version 11. But in the future, we'd like to actually go towards the more full life cycle. That way, when new operator code is pushed and new functionality, then it actually automatically updates. So it's that full life cycle of capabilities for the operator that we want to kind of move towards in the future. And then from there, to kind of further move along the hybrid cloud story, we'd like to actually use Quay in the same way that we just saw WordPress be deployed. Quay requires a database, it requires some object storage. So it actually paints a really good picture of the capabilities of both Crossplane and what we would actually need for a hybrid cloud scenario where you have resources on-prem and in the cloud or across various clouds. And then finally, we actually, with that functionality coming out, we'd have some upcoming blog posts on new use cases, functionality, features that'll be coming up along the way, just because just in the amount of time that we've worked with Crossplane, so many really cool things have came out that we want to kind of keep talking about the offerings, just because it really tells the story of the hybrid cloud so well.